Okay, today we're going to pull back the curtain on virtualization. This is the secret engine, really, the fundamental tech that powers pretty much everything we do online, especially cloud computing.
So here's our game plan. First, we'll look at the problem that started it all. Then we'll dive into the solution, virtualization, and see how it works under the hood. After that, we'll see how it's basically everywhere, clear up some confusion with the cloud, and wrap up with the one big idea you've got to remember.
All right, so to really get why virtualization is such a big deal, we have to go back in time. Before all this, the world was simple, but man was it inefficient. You had one physical server, a big metal box, and it could only run one operating system, which usually meant it was dedicated to just one main job.
And that created a massive problem. I mean, think about it. If your application only needed, say, 10% of that server's horsepower, the other 90% was just sitting there, wasted. It was like buying a giant mansion and only ever living in the kitchen. Just a huge waste of electricity, space, and a ton of money. So this whole issue, what we call the one-task server problem, it meant our data centers were just packed with these powerful machines that were barely breaking a sweat. Something had to change. We needed a really clever solution to unlock all that wasted potential.
And that solution, of course, is virtualization. At its heart, it's just a brilliant idea. It's a way to take one physical computer and digitally slice it up into a bunch of separate, totally independent virtual computers. Each one can run its own apps, its own operating system, the works.
And here's the textbook definition, which really nails it. You're creating simulated computers using just one physical machine. You know, a good way to think about it is to imagine that physical server is a big apartment building. Well, virtualization is the tech that comes in and builds all the walls and floors to create dozens of private, individual apartments inside that one building.
Okay, so how does this magic trick actually work? It really comes down to three key players. You've got the host, the guest, and this really important piece of software called the hypervisor.
It's all about layers. See, at the very bottom, you've got the physical server itself, the hardware. We call that the host. Then, sitting right on top of that is the hypervisor. The hypervisor is the manager, kind of like a traffic cop. Its job is to carve up all the host's resources, the CPU, the memory, the storage, and hand them out to the individual virtual machines, or guests, that live on top. And what's interesting is that this hypervisor, this manager, it comes in two main flavors. Type 1 is what they call bare metal. It's the super high-performance version. It gets installed right onto the server hardware, no other operating system needed. This is what the big guys like Amazon and Google use in their data centers. Then you have Type 2, or hosted. This one is more like a regular app that you'd install on your own computer. It's great for developers who need to, say, test something on Windows and Linux at the same time, but it is a little bit slower.
All right, now that we know how it works, let's look at where it shows up. Because this core idea of creating virtual versions of things, it has been applied to almost every piece of the computing puzzle. And you probably use a bunch of these every single day and don't even know it.
So first up, we have the classic, server virtualization. This is the original problem solver we talked about. Instead of needing 3 separate physical boxes for your web server, your database, and your email, you can just run them all as separate virtual machines on one box. And the impact here is huge, right? We're talking way lower electricity bills, smaller data centers, and it's just a whole lot easier to manage.
Next is desktop virtualization. With this, your entire computer desktop, all your files, your icons, your apps, it isn't actually running on the laptop in front of you. No, it's running on a powerful server, maybe hundreds of miles away. This lets a company give you a simple, cheap device to connect to a super powerful desktop in the cloud. And the biggest benefit? Security. If that laptop gets lost or stolen, no big deal. The data was never on it to begin with. Application virtualization is really, really clever. This is where the app itself is virtualized. So when you open something like Excel on your iPad, it's not really installed on the iPad. You're just seeing a video stream of it, while all the actual number crunching is happening on a server somewhere. This is an absolute game changer for IT teams. They can update the app once on the server, and boom, everyone instantly has the new version. No installs needed.
Now, network virtualization totally changed how we build computer networks. In the old days, you had to physically plug in routers and cables. Now, you can build incredibly complex networks complete with firewalls and all sorts of security completely in software. The key benefit here is speed. What used to take days of manual work can now be done securely in just minutes with a few clicks. And this whole concept, it's called a software-defined network, or SDN.
Storage virtualization is all about taming data chaos. It takes
hundreds or even thousands of separate physical hard drives and pools all their space together into what just looks like one giant single storage drive. This makes it way easier to manage tons of data, and it also makes it safer. Since your data is spread out across all those drives, if one of them fails, no problem. Your files are still safe.
And finally, there's data virtualization. Think of this as a magic layer that sits on top of all your different data sources. Your old databases, your new cloud files, spreadsheets, you name it. And it gives you one clean, unified view of everything. You can ask it a question, and it instantly pulls answers from all those different places, without you having to do the slow, expensive work of moving all that data into one central spot.
Okay, so you're probably hearing all this and thinking, wait a second, this sounds a lot like cloud computing. And you're not wrong, they are very closely related. But, and this is important, they are not the same thing. This is a super common point of confusion, so let's clear it up right now.
This table breaks it down perfectly. Look, virtualization is the technology. It's the tool that makes it all possible. Cloud computing, on the other hand, is the service that's built using that tool. So virtualization is all about getting the most out of the hardware, while the cloud is about delivering all those virtual goodies to you on demand over the internet.
So if you remember just one thing from all this, it's that relationship. If you get that, you really get the foundation of how the modern internet is built.
And honestly, this is the absolute best way to remember it. Virtualization is the powerful engine that does all the heavy lifting. Cloud computing is the car. It's the whole package, the service that actually uses that engine to get you where you need to go. Simple, right? You just can't have the car without the engine.
So, this incredible idea of separating software from the limits of physical hardware, it has already completely changed our world. And it's definitely not done yet. Which kind of leaves us with one final thought, right? Now that we know the secret, what's next? What part of our physical world is going to be turned into flexible, efficient software next?